You are listening to Season 6 of Future Ecologies.
Test 1, 2. Bumblebee tuna, rabble, rhubarb. Good to see ya. Okay, hi everybody. I am Mendel.
And I'm Adam.
And today we're joined in the studio by a red-legged frog. Potentially more than one red-legged frog.
A chorus of randy red-legged frogs recorded with a hydrophone during their breeding season in February in a half-frozen wetland that I helped to restore a couple of years back.
Recorded with a hydrophone because this species only vocalizes underwater.
Yeah, otherwise they are pretty darn quiet.
They're adorable.
And they make this sound all night long. Like up to 14 hours. Pretty chatty for a creature few people ever get to hear.
Yeah, for reasons not just that so few of us are underwater in February, but because the red-legged frog has been in steep decline for many years, due largely to the loss of wetlands throughout their range.
Which is one of the reasons why, Mendel, you and I share a hobby. In addition to making this show, which is that we both work to restore wetlands.
Well, that's charitable. You work to restore wetlands. I dabble in restoring a wetland. That is one little urban wetland in my neighborhood in Vancouver.
Yeah, it's a cute wetland, though.
I love it.
And to do that, we have both had the opportunity to work with the same remarkable woman.
What are we going to talk about?
Well, the very first thing to do is to introduce yourself. Who are you?
My name is Robin Anschild, and I design and build wetland and stream restoration projects.
On any given day, you're likely to encounter Robin up to her ankles in mud, sporting a hard hat and a high-vis vest, orchestrating the actions of up to a half dozen heavy machine operators, all working together to answer one important question.
What is it that we need to do in that watershed to restore a healthy relationship between the soil and the water?
And the reason that this question is so important is that we humans of the colonial variety have seriously disrupted that relationship, basically everywhere that we have settled. Across North America, over 50% of all wetlands have been lost since the 1700s. And that loss has actually accelerated in recent years, despite no net loss policies and mitigation efforts. It's even worse in some areas, like where I'm from in California, where over 90% of wetlands have been lost. In British Columbia, that number is closer to 70%.
And when you say lost, you mean?
Drained and converted for other uses.
We have significant cultural amnesia about how we've changed these landscapes where we live. In Europe, where certainly my ancestors came from, there had already been centuries, if not millennia, of a really systematic and highly sophisticated wetland drainage.
Because wetland is usually flat. Flat land is good for building things.
Wetland is also rich. Rich land is good for harvesting timber and growing crops.
Industrializing societies all over the world tend to take places that are wet, woody, rich, and wild, and reduce them to a blank slate for all kinds of development.
Creating those uniform conditions across floodplains is kind of the bread and butter of our way of living on the landscape. Simplifying streams so that instead of being broad and flat and flooding the floodplain perhaps on an annual basis, they are now in deep ditches that flow down a straight line, on the edge of the field. It never occurred to me that the very ditches that I played in as a child, I thought that those ditches had streams in them. Really, they were ditches draining wetlands. And that water that I played in those ditches was water being drained out of wetlands.
I also have fond memories of playing in ditches as a kid, on ag land that had once been in the floodplain of the San Joaquin River. The landscape changes that Robin is describing are ubiquitous.
Everything that we have done when logging, road building, mining, converting, wetlands and floodplains to agriculture has been about hastening the passage of the water through the watershed. And now what we're looking at is, well, now wait a minute. What if we wanted to invite that water to take a more leisurely path?
Many of our ancestors were trying to get the water off the land as fast as possible. And now, here we are, thinking the exact opposite. How do we keep the water on the land for as long as possible?
Wetlands, by their very nature, are dynamic ecosystems. One of the things that I find so exciting about wetland and stream restoration is that through a single action, we're achieving multiple benefits.
Like making habitat for endangered frogs.
As discussed. And also to recharge aquifers, sequester carbon, create fire breaks, and mitigate the destructive power of floods.
Wetlands absorb water. Imagine if you're running a bath and you pull the plug, and of course, it takes whatever time it takes for the bath to drain, but it drains pretty quickly. Now, if you were to fill your bathtub with towels, put the plug in, fill it up, then remove the plug, it's going to take a lot longer for that bathtub to drain. So when you have a high rainfall event, instead of all that rain hitting the soil, the ground, the surfaces of your watershed and running out quite quickly, the wetland is like that towel in your bathtub. It's absorbing all that water and it's releasing it more slowly. The cheapest way to prevent flooding is 1, to protect the wetlands that exist in your watershed, and 2, to restore drained wetlands in the watershed. So if anything, we need more wetlands. We need more capacity to absorb and regulate flow of water and clean surface water and inject water into the ground.
At this point, for me, this is gospel. But once Robin and the big yellow machines finish building the wetlands and they leave for greener pastures, then I'm left with the daunting task of getting native plants established again on these highly disturbed sites. Thankfully, my organization grows the plants that we need to do this. But there's been this thing nagging at me. In order to grow those plants, as part of the soil mix, we typically use a product that most folks are probably familiar with. It's called peat.
Peat. Fluffy, porous, great for growing blueberries, tasty and Scotch, and famously comes from bogs.
Bogs, which are, as a matter of fact,
wetlands. Is that a bit circular? That's a bit circular.
It's not ideal. And so my colleagues and I have been asking ourselves this pesky question. Should we really still be using peat to grow our plants for restoration? Wetland restoration.
Seems like a simple question. How hard could it be to answer?
How hard indeed. Well, on today's episode, for Peat's sake, we tell the story of peatlands in North America through one remarkable wetland and attempt to answer a seemingly simple question. But you know what happens to simple questions around here, right?
This sounds like it would be just an interesting sort of ecological exercise, right? But it became a very, very big political issue.
Come on in. The water's fine.
Broadcasting from the unceded, shared, and asserted territories of the Musqueam, Squamish, and Tsleil-Waututh. This is Future Ecologies, exploring the shape of our world through ecology, design, and sound.
To get to know Peat, you have to get to know Bogs. And so we're going to get all up in the business of the most charismatic bog that I know. If you were to visit Vancouver, nestled between the snow-capped mountains of the Coast Ranges and the Salish Sea, first you should say hi to Mendel.
I live here.
And then you should head south across the north and south arms of the Fraser River, through the suburb of Richmond, and you will see heavy industry, highways, subdivisions, farmland, until you hit the largest undeveloped urban landmass in North America.
And you're thinking, undeveloped, urban, landmass. What does that mean?
It's a good question. It basically means, I think, that it's a massive wildland in a major urban center, but that it's not a park. There is no public access here.
This undeveloped urban landmass is actually an enormous raised bog.
A big, beautiful bog by the name of Burns Bog. And since it's nearly impossible to access for most people living here, Burns Bog is actually kind of a big black box. A big black box that every so often bursts into flames.
Fire crews launched a rapid attack from the air and ground today in the hopes of knocking down a fast-growing brush fire that sparked in Burns Bog along a stretch of Highway 17 in Delta.
With an ecological treasure at risk, fire crews in Delta, BC threw everything they had today at the flames in Burns Bog.
But it is a difficult fire to fight, and officials say that it could continue to burn for days.
Remember the big fire they had in 2005 in the bog? Just hope it doesn't get as big.
So what's going on here? Well, we've got our bog, and now what we need is our bog whisperer.
Sometimes, with some stories, we have no idea who to talk to first. But for this one, all roads lead back to one man.
My name is Richard Hebda, and I am the curator emeritus at the Royal British Columbia Museum and an adjunct faculty at the University of Victoria, historically in the biology department, the School of Earth and Ocean Sciences, and School of Environmental Studies. With respect to Burns Bog, I was the government's scientific expert on the ecosystem review for Burns Bog 25 years ago.
And I will say, just from my experience, it's hard to throw a rock around here without hitting one of your students. Or one of the students of one of your students.
We hope people don't throw rocks at them unless it's because they're doing very good things and that people are scurrilous rogues.
Don't throw rocks at Richard's students, Adam.
I would never. But long before Richard had an impressive retinue of students, he was just a graduate student himself, looking for a project.
I had a background in earth history and in botany. So when I came here, my supervisor of the day, Dr. Glenn Rouse, said, there's this bog out there in the Fraser Lowland. We don't know very much about it.
And when a young scientist learns that we don't know much about a thing, it becomes almost irresistible.
This was a particularly interesting, different sort of creature, as it turns out, because Burns Bog is a raised bog, and essentially raised bogs make their own environment and essentially create circumstances by which plants that are critical in peat accumulation can thrive and continue. So the whole idea was, well, when and where did it come from? How did it arise? And sort of how does it work?
These were the questions Richard set about answering in his PhD.
How did it get here? It's kind of simple in one way. The Fraser River brings in mud, and it filled in the shallow waters. And in doing so, those lands emerged like the back of a whale out of the water. And in the process, as they emerge slowly, first being intertidal, seawater influenced, freshwater influenced, they go through a process of succession, of change, from lower intertidal plant communities through middle to upper intertidal freshwater marshes, as you see in the Fraser today. And then the organic matter accumulated as peat.
Peat, which is plants. All sorts of plants, in a state of arrested decomposition. Because the wet conditions of this bog in progress don't allow dead plants to fully break down into soil.
Which changes the surface chemistry. And that, in turn, changes the plant communities that can grow there. First, herbaceous plants, and then later, woody plants.
So willows, rhedos, your dogwoods, Pacific crabapple. And then those plant communities accumulate more peat, but now it's woody, and woody peat is much more acidic.
And as things become increasingly acidic, the plant community changes again. with Labrador tea, bog cranberry, bog rosemary, cloudberry, and the star of the show, a whole retinue of colorful sphagnum mosses.
Ta-da! That's the birth of a bog.
And once the sphagnum mosses begin to establish, they have all sorts of amazing tricks of organic matter chemistry, of water regulation, of being able to grow in situations where there's very low nutrients because the peat's accumulating above the water table. And then they essentially convert this wetland into their own home, in which peat mosses thrive and dominate. And once you get into that, they just keep adding more peat as their bodies don't break down, but as they die and only partially decompose, and more sphagnum mosses grow.
And over the course of about 4,000 years, those remarkable non-vascular plants, the sphagnum peat mosses, have essentially constructed a dome out of their own dead bodies, with a shallow living fringe on the surface.
And because it's higher in the middle than at the edges, like a dome, it becomes, get ready for this, ombrotrophic.
Ombrotrophic.
Ombrotrophic basically means rain-fed. The nutrients that enter the bog, that support the growth of all the plants and all the decomposers and then all the animals that depend on them, come from the sky. And that's because the bog itself is actually above the water table. So no water flows into it because it's higher than everything else. And it drains radially outward from the center of the bog, or sometimes they have ridges outward from the ridges to the margins. So the only source of water and the only source of nutrients is rainwater.
But that's okay, because the sphagnum peat likes low nutrient conditions. And the other plants that grow there, they have unique adaptations to live in this environment. For example, they learn to hunt insects.
Carnivorous plants are just amazing because they're essentially an inside-out stomach. They have the digestive juices on the outside, in the case of sundews, on these little glands with little glistening drops of fluid on the ends of the glands, and those are your digestive juices. So imagine the stomach is outside, dissolves insects that fall on it.
I love sundews. What the hell? Pitcher plants.
I know, we could have made the entire episode about them, but we're not going to do that.
So that's how these plants get their nitrogen and the other nutrients that they need, because they don't get them out of the ground very much, because there aren't very much, in a ombrotrophic bog.
And these unusual plants support an abundance of wildlife.
In my days, almost 50 years ago, there were bears and deer and all kinds of other wildlife, much of which is no longer there. To see a sandhill crane just, 15 feet away from you in a ditch could just all of a sudden erupt, a bunch of them erupt, and I go, oh my God, there's a black bear sitting in there, 10 feet away from eating berries. It doesn't even know I'm there. Then you see these majestic cranes just taking off as they do. Of course, you don't make any noise when you walk on sphagnum. It's cushioned. It's being returned to the bosom of the bog. You are part of it, encased in part in it, cushioned by it. And you appreciate it in a way that's just exceptional, because you hear the insects. You smell the smell of the bog, Labrador tea. You hear the birds, like the sandhill cranes, or the bumblebees flying around, pollinating the cranberry flowers, these gorgeous little pinkish cranberry flowers. You feel it, you smell it, you hear it, it's all there. And you feel as if you're part of it.
These are all reasons why, for Richard, bogs are more than just ecosystems.
The biosphere converts part of the earth into essentially a superorganism. As we in our own bodies have systems that work together and feed each other and support each other, this macroorganism, a raised bog, does exactly that same thing with a multitude of species and multitude of processes on a huge landscape. That's why I like bogs.
And Burns Bog is just one very southerly representative of the bogosphere, if you will, a patchwork that blankets the northern parts of the entire world.
Burns Bog is also representative of many bogs for another reason entirely. It has a long and complicated history of people trying to drain, farm, and fill it. Because when European settlers arrived, they simply weren't content to let sleeping bogs lie.
Settler history goes back to basically people trying to farm the land. They dug these ditches going into the bog, and they were visible when I was there, or they were invisible sometimes, and you would just fall up to your waist in peat and water.
Kilometers and kilometers of ditches, just like those that we discussed with Robin earlier. Speaking of which, Mendel, you want to know how you can get a bog named after you?
Ooh, how?
Try, mostly unsuccessfully, to get rid of it. Burns Bog is named after one Dominic Burns, a rancher who did his damnedest to drain it.
And that sort of went on for a while until the Second World War.
The Second World War, of course, interrupted all sorts of settler agricultural activity and also created whole new economies, including the use of peat moss for military first aid.
Antiseptic and absorbent.
There was quite a bit of extraction at that time for basically military purposes. But eventually, that became converted to the extraction of peat moss for horticultural purposes. And when that came around, then there was this huge extraction of peat from the middle of the bog. Its organic material, the peat, predominantly sphagnum peat, was removed. So the heart of the bog was taken out. But like my bald head, there was active living peat communities all around the edges. And they essentially sustained the bog, even though the middle had been taken out, and maintained the water chemistry in the middle so that the sphagnum mosses came back, essentially in a giant pool or a giant reticulate network with ridges of peat that remained in open pools.
So I guess you can actually teach an old bog new tricks.
Yes. But meanwhile, more mischief was afoot.
At the same time, as the inside of the bog was being exploited, dug out, people were nibbling on the edges, converting. Now, conversion, irreversible.
All around the bog, chunks of the edges were being developed.
There was the railroad construction, and then the road construction.
A highway went through it, the one, the Alex Fraser Bridge, which in my opinion never should have been allowed to be built the way it was, and the environmental assessment for it was utterly inadequate.
And then there are the cranberry farms.
Some of it was converted to cranberry fields because cranberry fields have turned out to be very lucrative.
And we'd be remiss not to mention the gigantic landfill for the city of Vancouver.
One of my study sites is now under the dump.
Meanwhile, peat extraction technology was advancing.
Later on, when they got very sophisticated, they would just cut the trees off and scrape it off and then suck the peat to giant vacuum cleaners.
Incidentally, cranberries are also harvested by giant vacuum tubes. I have seen it myself.
More sucking. There's a lot of sucking involved.
And all of this draining and scraping and dumping and sucking kept eating away at the edges of the bog. But no one seemed to put up much of a fuss. Parts of it would periodically burst into flames, but so what?
It's just a bog. Who cares? Bog, 3-letter word for bad things. Because, of course, everybody thinks they're horrible places. They don't value them, and they don't even understand them. They just throw more garbage on top of them.
And some major industrial development proposals were floated for the bog.
At that time, which was, I think, in the mid-'80s, the idea was they would dig the bog out and fill it with sand from dredging of the Fraser River, and then build a huge megaport.
That didn't pan out. And so then a 2,500-acre industrial development was proposed. And then a horse racing track. And then the Pacific National Exhibition, an amusement park, basically.
But by the 90s, some folks were beginning to recognize the value of the bog and just how threatened the remainder was.
There was a very strong community group with very skilled and capable people and knowledge who could make the case that this place shouldn't be filled and turned and burned and whatever else.
Finally, following years of public pressure and failed development proposals, the province of BC agreed to undertake an ecosystem review of Burns Bog. And they asked Richard to lead it, which initially he was hesitant to do. But
the bog had spoken to me a long time before, and I thought, okay, well, I owe it to these creatures, this amazing place, which gave me my future, which gave me my job, and has sustained me, has supported my curiosity. I am at one with the bog, and therefore, if I am at one with the bog, then I must be the bog. It's the way I looked at it. So I said, I'll do it.
And to make a long story short, he and a handful of other scientists did it in just 8 months.
You know, I pulled it off. I did it exactly as it should be done, in open public forum, with the scientists reporting. People like Ian McTaggart-Cowan, who were just unbelievably powerful when he came. Now, Ian McTaggart was the zoologist of British Columbia, a tall man with a powerful voice. And he just said, that red mouse, the redback vole, that red mouse, the last time it was seen in British Columbia was in the UBC endowment lands, and I and my wife saw it in the late 1940s.
When the report was finally published, the conclusion was stunning. It stated that the vast majority of the remaining bog area, over 2,000 hectares, would be required to preserve its viability and sustain its processes. And when it came down to it, Richard was called upon once again, this time by the lawyers, to actually delineate the area that would ultimately be protected, which was a real crisis for him as a scientist.
At that point, I truly understood that you cannot be an objective, dispassionate scientist. You cannot be one. Just as we face the future of climate change, we have to make the choices and the decisions and not leave them for the government to make or for an industry to make. We have to work to make the best decisions that are possible. And so I did it. So I drew the lines.
And from those lines would eventually emerge the Burns Bog Ecological Conservancy Area, managed by Metro Vancouver and the City of Delta to maintain it in perpetuity. The bog had been drained and sucked, battered and bruised, but now it had a fighting chance at life.
You know, why would you fill it and kill it? Why would you not think of it as one of the most biologically spiritual creations on the planet Earth?
The fate of one of the most biologically spiritual creations on planet Earth. And, I promise, eventually an answer to our question about peat. That's after the break. Now, if you excuse me, I have to go see a man about a bog.
Hey, if you're enjoying the show, check out futureecologies.net/support. Thanks.
Driving down this old gravel road. On my left, Burns Bog. On the right, cranberry farm. Actively harvesting. Group of men out in waders, water up to their waists, with a giant vacuum hose sucking the cranberries that are floating off of the water surface and into a giant bin. Wild. And another gate. I think this is the third gate. Gates everywhere.
Wait, I didn't get to go along for this ride. I feel so left out. I thought you said members of the public couldn't actually get into Burns Bog.
I mean, they generally can't, except for a tiny piece called the Delta Nature Reserve, which is nice to visit if you can. But I am no ordinary member of the general public, Mendel.
Uh-huh.
I have special clearance from a friend who got me inside.
I don't think I have ever eaten a fresh cranberry right off a bush.
Not a cultivar.
This is native.
Yeah.
That is delicious.
Tart though, eh?
Oh, but I love things that are sour. Oh my God.
That's good.
I love sour things. Oh.
Haha, yes, you were there to see your good friend, the cranberry.
Of course. And my colleague, Drew Elves.
I teach at University of Victoria in the Restoration of Natural Systems program and in the School of Environmental Studies. I am an ecohydrologist by training, a peatland ecohydrologist with a focus on sphagnum mosses.
So I'm standing out there in the bog with Drew, bobbing up and down on this thick mat of peat in the sun.
No, I'm not jealous. Thanks for asking.
And we're looking at this wild variety of colors all around us.
Like, we're looking at this field right now, and there's a cornucopia of color, right? There's so many greens, so many reds, so many buffs.
And these colors we're seeing, they tend to correspond to different species of sphagnum moss.
There are 12 documented species.
Growing in slightly different parts of the mossy landscape, the hummocks and the hollows.
The ones that make the hummocks, they are slow growing and they're recalcitrant, meaning they don't readily decompose. These recalcitrant hummock species are really resilient. They can take up water and stay moist much further into the drought period than hollow forming species. The hollow forming species, though, they'll grow really fast, but then they don't have the specific phenolics, meaning they don't have those chemicals that impede breaking down. Right? They're not robust in that way. They decay.
Tag yourself. I'm the not-so-resilient fast grower.
I'm recalcitrant, slow and stubborn all the way.
So it's two very different traits. One's a hare, one's a tortoise. The hare are the hollow-growing species. They'll grow really fast during a time when moisture conditions are right and temperature conditions are right, and they'll grow really quickly. So because of that, they are lateral growers, whereas these hummocks, they slowly build up. They have this apical bud, meaning a topmost layer where they keep growing from. And so they just keep growing higher and higher.
So it's a beautiful, diverse bog scene. But at the same time, this is a part of the bog that was harvested and prepared to be a cranberry farm before it was abandoned. It's still recovering from that disturbance.
The hydrology has been brought back to within historical bounds, and that means that peat forming processes have been reinitiated.
And Drew is there studying that recovery.
How is he doing that?
With light. And a very, very nice camera pointed directly at the ground.
We can take the properties of light. The sun comes in and it encodes a lot of information, especially for plants and photosynthetic organisms, right? What they use, what they take, meaning what part of the sun's light that they use at different times of year and then what they reflect back can tell us a lot about what's happening underneath.
And just as a very basic example, when sphagnum moss gets dry, it tends to turn white. And that increases the albedo of the bog, helping reflect sunlight and cool things down a bit. That's something that we can see with just our eyeballs. But Drew is looking at what we can learn with better equipment than what nature gave any of us.
The affordances we have in terms of our vision, they're not entirely objective, right? I often tell students, remember that dress?
You know the dress, right, Mendel?
The dress? Of course I do. It's obviously black and blue.
Oh no, it is clearly white and gold. What color was the dress?
I don't answer that question because I think as a lot of people who have a significant other, it maybe led to a bit of acrimony. And so I'm not going to say what color the dress was.
So instead of relying on his merely human vision, Drew is using the NDVI.
The what?
The Normalized Difference Vegetation Index. So that's where it goes from being the dress and being subjective to being something that's standardized and reproducible and decipherable.
And I brought us here just to say that this is a lot of what goes on in the black box of Burns Bog. It's basic science, developing techniques to better understand all bogs by studying the recovery of this bog.
That's so cool. And, how are things going?
Well, we did mention that the bog occasionally erupts into flames, right?
We did.
And that's because those kilometers and kilometers of ditches and roads crisscrossing the bog, many of them are still actively draining it, drying it out. And a big pile of dead, dry peat is a magnet for wildfire. This is the primary reason why the public isn't allowed in the bog.
Sure, that makes sense.
But in addition to researchers, there are also folks in here looking after the bog. And so I caught up with a couple of them on a group field trip on a freezing cold, rainy day. You're actually going to hear the raindrops hitting the microphone, and I just want you to know that every single one of them felt like frostbite on my hands.
Thank you for your service.
It is also on the flight path of the Vancouver International Airport, and so there was so much plane noise.
I'm Marcus Merkins. I'm a regional parks biologist and I've been working in the bog for the past 15 and a half years. Try and take care of the bog the best I can. I'm going to pass it over to Sarah here.
Sarah Howie, a climate action and environment manager with the City of Delta. I've been working in the bog since the year 2000, and Marcus and I co-manage the bog.
And without much further ado, they ushered us into the bog.
If you see what looks like a mud puddle, don't step there because it's basically a sinkhole and you will fall in. That would be a fun experience for you, but we'd rather you not have to deal with that. So you can just step on the vegetation instead. It'll keep you afloat.
Bogs are incredibly complex ecosystems, and to quote a professor of mine at UBC, bog ecology isn't rocket science. It's way more complicated than that.
Marcus told us that the peat in Burns Bog is 5 to 8 meters thick. And to demonstrate, he pulled out a Russian peat auger.
So I've just taken a core sample of the bog. This peat's about 1.5 meters below ground. This was sequestered at a time when the Vikings were exploring the eastern coast of North America. That's how long ago this was laid down.
Welcome back to the sunlight.
So, Mendel, as you know, normally bogs are too wet for anything but a few stunted trees to grow.
Mm-hmm.
But where we were walking, there were hundreds of dead, burnt-out tree trunks, and beneath them, thousands of stout little pine saplings.
If you look around us, you can see these burnt-out trees. These are the trees that release the cones and seeds post-fire. And if you look behind me, you can see the lodgepole pine stand. Very dense. If you have 6 trees in a square meter or square yard, you have 60,000 stems per hectare. So that's a huge number of trees.
Oh my God. What is it with us in the season and cataloging the density of stands of trees?
I have no idea, honestly. It is a through line.
Yeah.
There were a lot of pines there.
Yeah, what's up with that?
Well, when you start draining a bog, you make it a lot easier for trees to grow because it was the water level that was keeping them out. And when trees start growing, they start transpiring water. Lots and lots of that water.
Trees are hydrological pumps. Pine, a weaker pump than other species, but in the aggregate, 60,000 stems per hectare push a lot of water out of the bog.
They suck water out of the ground.
More sucking.
And then things get even drier still. And then they catch fire and burn. And then the seed cones open and thousands more trees start to grow. And the vicious cycle continues.
So what are they doing about it?
We physically remove by hand trees now over a 19 hectare or almost 50 acre section of the burn that happened, which was 37 hectares within the Conservancy area. So very labor intensive.
They rip up and pile the trees. I pulled a few myself just to be helpful, you know?
Oh, that is delicious.
Good, eh?
Oh, yeah.
Are you eating cranberries again?
Possibly. But more to the point, the trees are only one part of the problem. Those old settler drainage ditches are still doing their thing.
Ouch.
And as the bog is drying out, especially at the edges, the peat is subsiding away as it's being oxidized. with all of that carbon going back up into the atmosphere.
Whoa. It's kind of like the bog is still burning, only on a slower timescale.
Yeah, you could definitely look at it that way. And this edge of the bog, also known as the lag, is where organic peat meets the surrounding mineral soils. As Richard told me, it's really important.
You can't have a bog without a lag. Essentially, the lag is kind of like that transitional skin on your body. If you don't have that, if you just cut into the tissue and expose the raw flesh, you die, you scar, right? The more cuts, the more it's bleeding, the less chance it has to survive. And so we need to stop the loss of water, in this case, the lifeblood of the bog.
Fortunately, Sarah Howie is an expert on lags and how to revive them.
So Marcus has been talking about his big tree seedling removal project. My project that I've been working on for 20 years is restoring the water table in the bog. So there's about 100 kilometers of drainage ditches that were put into the bog during the peat harvesting days. So we're trying to reverse that and stop those ditches from draining. So we've got these dams, about 479 dams, and almost all of them were built by hand by people carrying materials and shovels into the bog, digging borrow pits of peat, filling the dams with peat, and actually using coroplast boards like these ones, recycled election signs.
Election signs?
Yes. Even bog restoration is political, Mendel.
After we would have a local election, they were really just going to dispose of them anyway. And so, they're buried. They're basically like sheet piling, and we use them to block the flow of water in the ditches and then cover it with peat so that the plastic is not exposed. It's buried basically forever in the peat.
Sarah says this works so well because the signs are really light and pretty tough. You can carry them into the bog on your back and create permanent ditch blocks.
And because we have to, walk for kilometers sometimes to get to the places where we're working, that's the best material. And we actually ran this by our scientific advisory panel before deciding to put this plastic in the bog. And they said because it's going to be buried essentially forever in the bog, it's inert, it's not contributing chemicals or nutrients. I mean, I don't love the idea of putting plastic out there, but it's buried and it's not damaging the bog in any way.
I guess sometimes practicality comes before romance. Are they also using like big, heavy machinery excavators like Robin?
At times, yeah.
It's actually the same excavator operator that was working for the peat harvesting folks, and now he's helping us with restoration.
Sarah told me that they've basically blocked off most of the ditches in the center of the bog. And so she's turned her attention to the lag.
The next goal is to restore the edge, and that's probably going to take me to the end of my career.
But that's all right, because, as Richard told us, they have a 100-year restoration plan in place for the bog. And we're just a quarter of the way into it.
I think that in the 25 years that we've been doing this work and gathering more knowledge, it's as well and better than I had hoped for.
You can see that especially in the middle of the bog.
The water levels are generally where they're supposed to be, within about half a meter of the surface.
But we're not out of the woods yet. Not by a long shot.
The other issue that we're dealing with is climate change. So we've re-wetted the bog, we've raised the water table, and now we're getting drier summers. And so it's much hotter and the water table is dropping.
And so Sarah will continue blocking ditches, and Marcus will keep removing trees, and Drew and other researchers will continue to study the system. And hopefully, in the meantime, the bog doesn't go up in smoke.
So it's great to hear that some level of recovery is possible, right? At least on a 100-year timescale. But it's clear that harvesting the peat from this bog, along with other disturbances, has had a pretty profoundly negative impact.
Which brings us back to the question that we started with. Can we justify harvesting peat from bogs so that we can use it to grow plants? Say, native plants, for restoration.
To answer that question, we needed to talk to one more person.
So my name is Lynn Rochefort. I'm a professor in restoration ecology, holding a chair in ecosystem restoration, and also I'm the North American national expert at the Ramsar Convention.
Lynn is widely recognized as Canada's leading expert on peatland restoration.
Canada, in terms of managing, caring for peatlands, has a world responsibility, because we have a lot of carbon stock in our peatland. 34% of all the peatlands in the world are in Canada,
followed by 33% in Russia. So between our two circumboreal nations, there are 2/3 of the world's peatland, which is a lot of carbon. Now, Lynn is quick to point out that peatland destruction is a serious issue at a global and a regional level, especially in the more developed parts of southern Canada.
Like the Fraser Valley, where Burns Bog is located.
But overall, she says, of Canada's total 128 million hectares of peatland, only a tiny fraction have been directly impacted, estimated at less than 2%.
These and the numbers that follow are from the 2022 UN Global Peatlands Assessment, by the way.
So in Canada, if we go by order of impacts, through time we have drained for agriculture 1.3 million hectares of peatland about.
And after agriculture, the next biggest impact to Canadian peatlands is actually the fossil fuel industry.
Second in line is the oil and gas. And we don't have national statistics about all our impacts. But we do know that it's about 400,000 hectares. So it's an order of magnitude less than what happened with agriculture.
And after fossil energy, next comes hydroelectricity.
Hydro dams, so a lot of flooding in peatland-rich area, be it in Quebec, Newfoundland, Manitoba.
And then it's good old-fashioned drainage.
Some drainage for forestry, for urban expansion, road development.
And finally, we have the subject of our inquiry, peat extraction, for peat extraction's sake.
One of the least is using it for peat since 1931, about 38,000 hectares.
In other words, the area of peatland that has been impacted by harvesting for horticultural uses is absolutely dwarfed by the area impacted by agriculture, oil and gas, and other forms of development, all of which has only impacted a small portion of the bogs in Canada. But even so, when you go to the store and buy a bag of peat, chances are good that it's coming from right here in Canada.
Canada is one of the biggest peat producers in the world. The use of peat in Canada is really in horticulture. 85% is sold in the United States. It's for the professional grower, in greenhouses, cucumber, green pepper, tomatoes, and the mushroom industry.
So for Canada, peat is largely an export industry. Historically, some of that peat was harvested from bogs in Western Canada, like Burns Bog, especially after the Second World War. But for the most part today, that peat is coming from the vast boreal peatlands of central and eastern Canada. And before we continue, it's important to mention that much of Lynn's research has been funded and undertaken in partnership with the horticultural peat industry, something that she is proud of.
What I would say is that it's an industry that really care about managing their resource because it's really their living, and usually they are family-based type of companies also. They've been investing since the end of the 80s to develop peatland restoration measure or to manage better. I've always been a big believer that it's good that more biologists, environmentalists, and all that should work with industry to find solutions.
So Lynn is sympathetic to her industry partners. And to be fair, they've come a long way together.
Before I started, nobody knew how to manipulate mosses on a large scale with machines without killing everything.
To address this, Lynn and her colleagues in the Peatland Ecology Research Group eventually developed what has become known internationally as the moss layer transfer technique. To make a long story short,
it's very technical, but in peatlands we have two hydrological layers. One is called the aquathelm, the other one the catothelm.
The catothelm is the thick mass of dead peat that's typically below the water table and storing most of the carbon.
And the acrothelm is the thinner layer composed largely of living peat on the surface. Kind of like your skin. No, wait, kind of the opposite of your skin. Kind of like a tree. Wait, no, kind of the opposite of a tree. It's pretty different.
Yeah. So it's the first 10 or so centimeters of the acrothelm,
where there's all the propagules, spores, seeds.
Everything you need to catalyze the recovery of a bog that's been harvested.
Once you have a peatland that's been drained for maybe 20 years, we need usually to reprofile to a fresh peat because we really need to have a good contact by capillary rise of the water.
And so the top 10 centimeters of acrothelm is collected from a donor site, usually the next site to be harvested, and then is spread on top of the restoration site.
So once we spread all our material, then we need to protect it with a straw mulch, usually that we use. It's to create a microclimate because the mosses have no roots.
And in addition to straw mulch, they add phosphorus.
Because phosphorus is good. It's not necessarily there to help the sphagnum, but it's another moss that we need, a nursing plant, we call it, Polytrichum.
Go into any bog, and amidst all that fluffy sphagnum, you're likely to see other mosses, including the pointier Polytrichum, looking like a miniature palm tree, or as Lynn calls them, little aloes.
Or pineapple, because they have all these spikes on the edge.
I found this aspect particularly fascinating. Lynn and her colleagues have discovered that a little bit of phosphorus really helps Polytrichum to establish in the transplanted sphagnum, and this Polytrichum is much taller than the sphagnum.
So that's why if you get this Polytrichum nice carpet to establish, then it binds the peat and also creates a nice microclimate.
And that miniature forest of Polytrichum protects the sphagnum moss from destruction through frost heaving, which otherwise can be really damaging in northern climates.
The sphagnum survive there, like, in the shadow, but they take over because they are eco-engineer type of organism.
That's so cool.
Yep. And then the last step, you re-wet the bog.
You have to re-wet. You have to block the ditches.
And that's about it. Presto. There's a functional bog once again.
Yes, we do get a bog at the end of it. We have a rate of 75% success.
Based on Lynn's monitoring work, it takes about 9 to 12 years for the bog to once again become a carbon sink, and about 20 years to fully offset the carbon cost of the restoration.
The biodiversity in terms of vascular plants, we know that after 5 years, we're getting 82% back. What does not come back easily is like orchids, but they have a complicated reproductive cycle.
So it's pretty good, but not perfect.
Restoration just never is. But as far as Lynn is concerned,
in Canada, sphagnum-dominated peatland restoration is close to a solved problem.
She's now turned her attention to the restoration of fens, which are a different kind of peatland, and to mitigating the impacts of wildfire on peatlands, which is an emerging and very pressing issue.
Yes. So, to return to our question, what does Lynn think about using peat for restoration and for horticulture?
Well, I see peat, it's a bit hard to replace for now. I think we should not stop ourselves from finding solution of other growing substrate.
But, she argues, all of the alternatives currently on the market have their own issues. Wood chips, for example, are not a great replacement.
Productivity, when you're using just wood chips, goes down quickly when you don't have, at least mixed with some sphagnum.
And rock wool, also used in home insulation, takes a lot of energy to produce and isn't biodegradable.
Piles of things that goes in the dump do not decompose.
Coconut coir, while it is a byproduct of palm plantations in India and Sri Lanka, has serious labor, land use, water use, and transportation issues to consider.
Coconut fiber, it is a good growing substrate, but its ecological footprint, you really have to look at your whole life cycle analysis.
Plus, something we weren't even thinking about. Perlite, which is often used in soil mixes, is a mineral which itself is extracted and processed in a very energy-intensive way.
Make sure you don't do mixes with perlite. Because the perlite, if ever it goes in the environment, it floats, and then amphibian can choke on that.
Lynn pointed us to the only peer-reviewed study that we could find specifically on our question, which performed a life cycle analysis of the environmental impacts of peat extracted in Latvia compared to imported rock wool and coconut coir. Latvia, incidentally, also exports about 85% of its peat, just like Canada. The researchers found that the full life cycle impact of coconut coir was 7 times higher than that of peat. Rock wool, significantly better than coir, but still higher impact than peat.
To our knowledge, there is yet to be a similar study on Canadian peat, but it's likely that the results would be pretty similar. So it would appear that all of the commercial alternatives to peat for horticultural use are, at best, flawed, and at worst, worse.
Still, does that mean that we should be using it? We asked some of the other folks that we spoke to. This is Drew again.
I bought peat for the first time in my life this past spring, and it was because we were planting bog Labrador tea in this small pocket bog, this engineered bog in a place of medicine at UVic. How did it feel? Really complicated.
And Richard is an interesting case because in addition to being a bog restorationist, he's also a serious horticulturalist. Besides Burns Bog, his other big project is studying the productivity of potatoes under climate change. And he strikes a cautious note on the subject of peat.
I think for certain kinds of horticultural uses, sphagnum peat is the best choice, and that would be things like rhododendrons, things that require acidic environments.
As for the alternatives, he acknowledged that there are life cycle issues, but he turned the question on its head a bit.
What's renewable on a short time scale? Coconut husks, not sphagnum moss on peatlands.
And while he recognized the work of Lynn and others in this area,
Dr. Rochefort has shown, yes, you can recover small-scale excavations of peat and bring back peat species, but you have very strong constraints on what you can do.
He also argues that what is lost is more than just carbon dioxide.
The consequences on large areas of peatland being harvested for peat takes away millennia of organic matter accumulation and disturbs that peat ecosystem. And on the basis of what we need to use peat as just as an organic matter in soil, I think it's not appropriate, not for large scale. This is where we need to be growing all kinds of organic matter and returning it to the ground and into our ecosystems.
Like compost, he says. Lots of compost. It's not a perfect peat substitute for some uses, but for others, it definitely gets the job done.
Yeah, I think we can all get behind that. So, to finally summarize the answer to our question, synthesized from all of these conversations in the style of Michael Pollan, use peat, not too much, and whenever possible, use compost instead.
And if you do use some peat, always keep in mind that what you're using is part of a superorganism.
The bog is a quintessential embodiment and example of what goes on all over the natural ecosystems of our Earth. So the hydrosphere, the water table, the atmosphere, the source of the rain and the oxygen that they need, the carbon dioxide that they need, the geosphere, the physical substrate upon which the conditions are such that the sediments, the peat, can accumulate to support all the living creatures. The living creatures of the raised bog, which you can draw a circle around. And it's a porous boundary, but there is a boundary, and you can see it and understand it as a physical structure, living in equilibrium, a dynamic equilibrium that it's shaping for itself with the hydrosphere, the atmosphere, and the geosphere. And now we face the greatest challenge of all, where the sociosphere is now of a scale equal to the other four spheres in terms of shaping the land, but not in equilibrium. And what's the fundamental lesson from those other four spheres? They will bring us back into equilibrium. And we all have to take responsibility to speak for them, to listen to them, and speak for them.
In this episode, you heard the voices of Robin Anschild, Richard Hebda, Drew Elves, Marcus Merkins, Sarah Howie, and Lynn Rochefort. Music by yours truly, Thumbug, and Sunfish Moon Light. Special thanks to the Wetland Project, Brady Marks and Mark Timmings, for letting us use a clip from their incredible 24-hour recording of a marsh on Tuktexan Saturna Island on unceded Wasanich territory, and to the organizers of the 2024 SER North American Conference, Tony Ballard specifically. Thanks. If you like what we do here, you can help us do more. Check out futureecologies.net/support to find out how. Thanks to all of our patrons who keep us independent and ad-free. We just could not do it without you. This episode was produced by Adam Huggins and me, Mendel Skulski, with help from Eden Zinchik. And as always, you can find a transcript and citations on our website, futureecologies.net. That's it for this one. We'll see you soon.